The vast expanse of space holds countless wonders, but it also presents us with potential dangers. One such danger has emerged from the depths of our solar system, Asteroid 2024 YR4. This celestial body was first detected on December 25, 2024, by NASA's Atlas system. The asteroid is estimated to be between 40 and 90 meters wide, roughly the size of a football field. While this may seem small compared to the vastness of space, an impact from an asteroid of this size could have devastating consequences. The discovery of 2024 YR4 has sent ripples of concern through the scientific community and beyond. Its trajectory suggests a potential impact with Earth, and the consequences of such an event could be catastrophic. The asteroid's size and speed mean that it carries an immense amount of energy. If it were to collide with our planet, the impact would release this energy in a devastating explosion, potentially causing widespread destruction. The potential threat posed by 2024 YR4 is a stark reminder of our vulnerability in the cosmos. While the Earth is a relatively small target in the grand scheme of the solar system, the sheer number of asteroids and comets whizzing through space means that the possibility of an impact is always present. Understanding the risks posed by these celestial wanderers and developing strategies to mitigate those risks is crucial for the long-term survival of our species. Scientists have been diligently tracking the trajectory of 2024 YR4 and calculating the probability of an impact with Earth. Initial estimates place the probability at 1.3%, but this figure has fluctuated over time as more data has been gathered. As of February 18, 2025, the probability of impact had risen to 3.1%, or a 1 in 32 chance. While this may seem like a relatively low probability, it is still a cause for concern. The potential impact date for 2024 YR4 is December 22, 2032. If the asteroid were to strike Earth, the impact corridor, or the area on Earth that could be affected, includes a wide swathe of the planet. This corridor stretches from the eastern Pacific Ocean across northern South America, the Atlantic Ocean, Africa, and the Arabian Sea, all the way to South Asia. Worryingly, this impact corridor includes two of India's most populous cities, Kolkata and Mumbai. The potential damage from an impact by an asteroid the size of 2024 YR4 is significant. The impact would generate an explosion equivalent to millions of tons of TNT, creating a massive shockwave and intense heat. The blast radius could extend for hundreds of kilometers, causing severe damage to infrastructure, buildings, and human life. The impact would also likely trigger secondary effects, such as wildfires, tsunamis, and widespread dust and debris in the atmosphere, further compounding the devastation. To assess the potential threat posed by near-Earth objects like 2024 YR4, scientists use a tool called the Torino scale. This scale ranges from 0 to 10, with 0 representing no hazard and 10 representing a certain collision with global consequences. 2024 YR4 is currently rated a 3 on the Torino scale, meaning that it poses a 1% or greater chance of collision capable of causing localized destruction. While this rating is concerning, it is important to note that the vast majority of objects that are initially classified as potentially hazardous are eventually downgraded as more observations are made and their orbits are better understood. Since its discovery, 2024 YR4 has been under constant monitoring by astronomers around the world. These scientists are using powerful telescopes to track the asteroid's movement and refine its trajectory. The data collected from these observations is crucial for determining the likelihood of an impact and for developing potential deflection strategies. The asteroid will be observable until April 2025, after which it will be too close to the Sun to be seen from Earth. It will become visible again in 2028, providing another opportunity for astronomers to study it. The International Astronomical Union's Minor Planet Center, which is responsible for collecting and disseminating information about asteroids and comets, issued a warning about 2024 YR4 on January 29, 2025. The MPC's warning emphasized the need for continued monitoring of the asteroid and called for international cooperation in developing strategies to mitigate the potential threat. The potential threat posed by 2024 YR4 highlights the importance of developing effective strategies for deflecting asteroids that are on a collision course with Earth. Several deflection methods have been proposed, each with its own advantages and challenges. One promising approach is the kinetic impactor, a technique that involves crashing a spacecraft into the asteroid to alter its trajectory. This method was successfully demonstrated by NASA's Double Asteroid Redirection Test mission in 2022, which successfully altered the orbit of a small asteroid moonlet. Another potential deflection strategy is the gravity tractor. This method would involve using a spacecraft's gravitational pull to slowly tug the asteroid off course. While this approach would require more time than a kinetic impactor, it could be a viable option for larger asteroids or for situations where a more subtle nudge is required. In extreme cases, nuclear deflection, which involves detonating a nuclear explosive near the asteroid to vaporize part of its surface and create a thrust that alters its path, might be considered. However, this option is controversial due to the potential risks and ethical considerations associated with using nuclear weapons in space. Regardless of the chosen deflection method, early action is crucial. The more time we have to alter an asteroid's trajectory, the smaller the deflection needed to avert a collision. Waiting until an impact is imminent would severely limit our options and increase the likelihood of failure. The potential threat posed by 2024 YR4 and other near-Earth objects underscores the importance of investing in space exploration and planetary defense. By expanding our knowledge of the solar system and developing the technologies needed to protect our planet, we can help ensure the long-term survival of humanity and the preservation of life on Earth.